In this lesson, I'll show you how to derive Euler's formula from a power series. This can be accomplished by substituting simply jx, where j is the imaginary unit, times x in place of x of the power series for e to the power of x. The power series for e to the power of x is shown right here. And wherever you see an x, I'll place jx. Let's go ahead and do that. We have e to the power of jx is equal to 1 plus jx plus jx raised to the power of 2 over 2 factorial plus jx raised to the power of 3 over 3 factorial. And I'll go to one more term for good measure. Plus jx to the power of 4 over 4 factorial. Let's simplify each of these terms wherever we can. One will stay the same. This will stay the same. Plus, now this 2 will be distributed to the j and to the x. And if you recall, if we have the imaginary unit j raised to the power of 2, that's like saying the square root of -1 times the square root of -1, and that is equal to -1. So we have -1 times x to the power of 2 over 2 factorial, which is simply 2. Plus, now we have j raised to the power of 3. I'll do my work over here. J raised to the power of 3 is equal to the square root of 1 times the square root of 1 times the square root of 1. That gives us negative j. Let's write that down. Negative j, x to the power of 3. 3 factorial is 3 times 2 times 1, which is 6. This one over here will do the same thing. If you have the imaginary unit j raised to the power of 4, or any multiple of 4, it's equal to 1. So we can simply write down plus x to the power of 4 over 4 factorial. 4 times 3 is 12 times 2 is 24. Plus everything else. Now let's clean this up further and see if we can collect like terms, because we have this term and this term both have a j. They are alike, so we can collect like terms there by factoring out the j. So we have 1, and I'll skip this one, write this one next, minus x squared over, and instead of 2, I'll write down what it was originally, which was 2 factorial, just for the sake of the next step. We'll skip this term and put that one next, x to the power of 4 over, remember this was 4 factorial. Now I'll write down these two, plus jx minus jx to the power of 3 over 3 factorial. Like I mentioned earlier, I will be factoring out a j from these two terms. If I do that, I end up with j bracket x minus x to the power of 3 over 3 factorial. And for these three terms, I have 1 minus x to the power of 2 over 2 factorial plus x to the power of 4 over 4 factorial. And just like these two, this is continuous. If you recall, this right here looks like the Maclaurin series for cosine. So we can replace this with cosine x. And this, if we continue on, will look like the Maclaurin series for sine. So I'm going to replace this with j, our imaginary unit, times sine x. This is equal to e to the power of jx, and that right there is Euler's formula. And so there you have it. That is how to derive Euler's formula from a power series.